Welcome to our exploration of the intricate relationship between urban areas and extreme weather events. In this video, we will delve into 5 key ways that cities amplify the impacts of climate change, from the urban heat island effect to the mechanisms behind enhanced storm intensity. We'll also discuss how altered wind patterns, reduced water absorption, and poor air quality contribute to these severe weather phenomena. Join us as we uncover the science behind these issues and their implications for urban living. 1. Urban heat island effect. The urban heat island (UHI) effect is a well-documented phenomenon where urban regions experience higher temperatures than their rural counterparts. This occurs because materials like concrete, asphalt, and buildings absorb heat during the day and release it slowly at night, maintaining higher temperatures. The lack of vegetation in cities, which would otherwise provide shade and promote cooling through evapotranspiration, exacerbates the UHI effect. As a result, cities can be several degrees warmer, which might seem trivial but has profound implications. During heat waves, this temperature difference can transform urban areas into veritable ovens, increasing the severity and duration of heat events. This intensification leads to more heat-related illnesses and even deaths, especially among vulnerable populations like the elderly and those with pre-existing health conditions. 2. Altered wind patterns. Tall buildings, while iconic of urban skylines, play a significant role in altering natural wind patterns. These structures can create wind tunnels, where gusts are intensified, or calm zones that trap heat and pollutants. This disruption in airflow means that localized air temperatures can rise, further worsening the heat experienced during extreme weather events. Additionally, these altered wind patterns can lead to poor air quality, as pollutants become trapped in certain areas. During storms, these wind disruptions can also have practical consequences, affecting everything from pedestrian comfort to the structural integrity of buildings. The compounded effects of altered wind patterns mean that cities face unique challenges when it comes to managing air quality and temperature extremes. 3. Reduced water absorption. Urban areas are often characterized by impervious surfaces such as roads, sidewalks, and buildings, which prevent rainwater from naturally soaking into the ground. This contrasts sharply with rural areas, where water can be absorbed by soil and vegetation. As a result, when heavy rainfall occurs, water rapidly accumulates on these impervious surfaces, leading to urban flooding. Drainage systems, often inadequate for handling such volumes of water, become overwhelmed, resulting in streets turning into rivers and infrastructure being damaged. This situation is exacerbated by the increasing frequency of intense rainfall events, linked to climate change. The inability of cities to efficiently manage water absorption not only heightens the risk of flooding but also poses significant challenges for urban planners and policymakers. 4. Enhanced storm intensity. Cities are not just passive recipients of extreme weather, they can actively contribute to the intensification of storms. Urban areas release heat and pollutants, which can act as nuclei around which clouds form, intensifying thunderstorms and rainfall events. This phenomenon means that cities can experience more frequent and severe storms compared to surrounding areas. The implications are significant, with increased risks of flooding, infrastructure damage, and even power outages. As urban areas continue to grow and industrial activities increase, the potential for enhanced storm intensity becomes more pronounced. The challenge lies in finding ways to mitigate these effects, ensuring that cities remain resilient in the face of increasingly severe weather conditions. 5. Poor air quality and heat interaction. Urban areas are hotspots for pollution, with emissions from vehicles, industries, and other sources contributing to poor air quality. When these pollutants interact with heat and sunlight, they form ground-level ozone and smog, which are harmful to human health. During heat waves, the situation worsens, creating a dangerous feedback loop. The combined effect of high temperatures and poor air quality can lead to severe respiratory and cardiovascular problems, exacerbating health issues among city dwellers. This interaction between air quality and heat is a growing concern, especially as climate change leads to more frequent and intense heat waves. Addressing this issue requires coordinated efforts to reduce emissions and improve air quality in urban areas, safeguarding the health of millions.